In this video, we're going to look at inequalities, how to put them on a number line, and also how to solve for inequalities. So let's first of all just look at this number line here. We're starting at 0, going in the positive direction, going in the negative direction. You've been looking at those since you were in Year 7. What about if I asked you on this number line to represent the place where x equals 2? Very simply, you're going to just put a little dot here. That's where x equals 2. That's pretty simple. But what about if I change this sum to be x is greater or equal to 2? X can be anything so long as it's bigger or equal to 2. Well, this is where it's equal to 2. All of these numbers here are bigger than 2. So to represent this, we can go 2 and everywhere above, because we're not just talking about the whole numbers, 3, 4, 5, 6, but all of the smaller decimals, all of the smaller fractions within there. So we need to include the whole lot. Okay, what about if I ask you to represent the numbers where x is less than or equal to 3? Find 3 on the number line, there it is. So x can be any number so long as it's less than or equal to 3. All of these numbers here are less than 3. So our representation would be 3 and anything less than. And just put an arrow on it to show that it goes on forever. Let's get another one. Oops. Alright, what about if I had x strictly greater than minus 4? Now notice I haven't put the little equals underneath. So that means that x is actually not allowed to equal minus 4, but it has to be bigger than minus 4, but it's not allowed to be equals. So to put that on a number line, here's minus 4. And it's got to be anything bigger than. But by putting a little dot here, that's signifying, like we had up here, that that number was included. It's not allowed to equal minus 4. So to represent that on a number line, we put an open circle at that point and then say anything above. So the open circle is saying start here, but it's actually not included, but anything bigger than it is. So 4.00000, as many zeros as you like, 1 is included. It's just that minus 4 that is not included. So to sum that up, a closed circle is included, and an open circle is not included. And I've got that summarised on the slide a little bit later on, so don't stress if you don't get that down. All right, let's move on. Let's write an inequality for these 4 things here. So let's have a look at our number line. It's starting at minus 2 and it's everything to the left of it. Because we have an open circle, that means that our minus 2 is not included. Our default pronumeral is x, so x has to be less than minus 2, and it's not allowed to include minus 2, so we're not going to put that equals on. This second one, though, we've got the closed circle, so x can be anything so long as it's less than minus 2. It can also be equal to minus 2, so we put the equals on. This third one here, minus 2 and to the right, open circle. So x can be any number so long as it's bigger than minus 2. It's not allowed to equal minus 2 because it has an open circle. The closed circle here means that we're allowed to have an equals. So that's greater than or equal to minus 2. So make sure you see the relationship between a closed circle and the equals. An open circle doesn't have the equals on it. sometimes we have what's called a double-ended inequality. So rather than just have an open and a closed circle and then an arrow heading in either direction, we've actually got an open and a closed circle on either end. Open and a closed circle on either end. To write this one, have a think about what we're looking at here. We're saying that we're looking at any number that is between 8 and 11. So our x can be any number so long as it's between 8 and 11. So we physically write the x between the 8 and the 11. Now we're always going to put less thans in here. That's not negotiable. Don't think about whether it's a greater than or a less than. It's always going to be less thans. The only decision you have to make now is whether to put the equals on it. This end here is an open circle, so it's a strictly less than. This end here has a closed circle, so it's included, so I'm going to include the equals on that. So this is saying that 8 is less than any value we want, which is true, and the values we want are less than or equal to 11, which is true as well. Let's practice that again on this second one. So the numbers we're looking at are between -1 and +1. So we can have any number so long as it's between -1 and +1. Less thans have to be less thans. This end here has a closed circle, so I put an equals on it. This end here has an open circle, so it doesn't have the equals on it. It's got a strictly less than. So that's saying that -1 is smaller than any number that we want, and the numbers we want have to be smaller than 1. This is a double-ended inequality. So what I've just talked about there is summarised on this slide here, and I've taken this from your book. So spend some time just having a look through that and making sure you've got something similar written down in your books, explaining the difference between open circles, and closed circles, and their relationship to less thans, less than or equals, and greater thans, etc. All right, when we're solving inequalities, we're going to just follow the same basic rules as we do for normal algebraic solving, except we just have to think about which direction our inequality is going. When we get an answer, we're asked to graph the solution on a number line. So let's have a look at part A. We've got 3x plus 4 is greater than 13. So what we would do is take 4 from both sides. So I'm going to have 3x is greater than 9, and then divide by my 3. So x is greater than 3. Finished. X is greater than 3 on a number line. Let's just quickly draw one up. There's 1, 2, 3, 4, 5. X is greater than 3. It doesn't say that it's allowed to be equal to 3, so I'll have an open circle and anything bigger than 3. Let's have a look at part B here. Now I'm going to just rewrite this because I like to have my x first. So I'm going to write this as minus x on 3 and a plus 4 less than or equal to 6. So all I've done is pick that bit up and put it in front of this bit, and remembering that there's a plus in front of that 4. Okay, using my algebra, I'm going to take 4 from both sides here, so I'll have minus x on 3 is less than or equal to 2. I haven't done anything to the inequality, it's just come along for the ride. It just, you can see here I didn't change anything. Then I'm going to multiply by my 3, so I'll have minus x is less than or equal to 6. Now, remembering that there is a 1 in front of that, I've got minus 1 times x is greater or equal to 6. The only trick you need to remember when you're using inequalities is as soon as you divide or multiply by a negative number, now just when you're writing this out, keep going underneath, I've just run out of room, I'm going to change the direction of my inequality. So my 1's have cancelled out. My less than or equal to is changing to a greater or equal to. My 6 divided by minus 1 is minus 6. So anytime you multiply or divide by a minus number, you change the direction of your sign. On a number line, x has to be bigger or equal to minus 6. So there's minus 6, minus 5, minus 4, minus 3, etc. Bigger or equal to, so I can put a closed circle, and there you are. Okay, and the last one. Now, when you've got when you've got pronumerals on both sides, you've got to get them all together. I like to just put all of the x's on the left and the whole numbers on the right. You've done lots of these as equations, but not necessarily inequations. So I'm going to take 6x from both sides. So I'm going to have minus 3x plus 2 is greater than minus 4. Now I'm going to take 2 from both sides. Minus 3x is greater than 4. Take away another 2 is minus 6. Then I'm going to divide by minus 3 to get x by itself. I'm dividing by a negative number, so I'm going to swap my inequality over, and then minus 6 divided by minus 3 is plus 2. X has to be less than positive 2 on a number line. 0, 1, 2, less than 2, not allowed to equal 2, open circle to the left. And that's pretty much it. You should be able to finish off that exercise on solving inequalities now.